Hello. Am I audible, students? Hello. Can you hear me? Hello. Hello, students. Am I audible? Steven, Akshay, Sanjana, Kirti. Am I audible? Hello.
Yes, ma'am.
Okay. So I'll just show you the slides. You just check it out. Are you able to see the slide movements? Okay. Can you see the slide movement, students? Can you see the slide movements? Yes or
Yes,
no?
ma'am.
Okay. Fine.
Yes, ma'am.
Right. Right. So in the last class, we have started with the structure of C language. You already know what the structure of C is having, and you have to follow the same structure to play with the C language. Okay, it consists of documentation section or the comment session. Please remember, comments are purely meant for the end users. It is an optional field. If you want, you people can add this comment. Otherwise, you can leave. You have two types of comments. One is single line, another one is multi-line. Then you have preprocessor directive. So whichever command or the syntax that you are going to use inside your program, depending on that, the preprocessor directive that you are going to add is going to change there. If I quote an example for this, if you are reading something, if you are printing something, so I'll be using scanf, printf, something like that. Okay, to use those particular syntaxes inside our program, we need stdio.h header files must be included. So it is part of the preprocessor directive or linking section there. Then you have the global variable declaration and a function declaration. So I have already mentioned, so I'll not repeat that, but the usage of this will be dealing in depth once we study the third and the fourth model there. Okay, then you take any function. Okay, so every program must have main. Okay, without that main, we are unable to do anything. Okay, every program must have main. So this is very important thing. Okay, because students forget to write this main itself. Okay, without this main, your program is not going to work. Okay, your compiler will not accept. So it is always searching for this main. If your program is having this main, so execution will start from that particular main itself. Okay, what it consists of? It consists of two parts. One is a declaration section, another one is the executable part. And you can write this main in variety of ways. I already mentioned you can use int main there, or you people can go ahead with simply main there, or you people can go ahead with void main. Void means no value. Okay, so main is not at all going to return any value. Integer means main is going to return an integer value to the operating system there. This is what I have mentioned, right? So that's why if you are writing it as int main there, the last statement inside a opening and a closing brace of this particular flower brace is the return 0. Okay, you have to use return 0 before you use the closing brace there. Return space 0. Okay, and ends with the semicolon there. So that you have to use if you are writing something called as the int main there. Okay, so then after this writing the main program, if you want to write your own programs that you have already declared here, so you people can write those things inside the subprogram there or functions there. Okay, this is the structure of a C language. Then once we know about this, so we wrote simple program for it. Okay, now so here I am interested to show you the working of this. Today I'll take one example and I'll try to show the same thing with the execution on the system itself on particular IDE. So before that I wanted to say something like, okay, IDE. Okay. IDE is nothing but integrated development environment. The meaning of this is I need some platform to type my instructions there. Okay, so I need to have, where I have to type my instructions. I need something. Okay, so for that we have something called as the editors. So these editors are provided by some of the IDs there. So almost all kind of IDs supports the C language there or C compiler there. Okay, so meaning is that you are able to get the variety of editors on variety of IDEs there. So to quote some of them, so you have something called as Turbo C++, this is one IDE. You have something called as Dev C++, okay, so this is another IDE. Okay, if you go ahead with something called as the code blocks, so you have another IDE that is available to write your C program there. So variety of editors that are available. So depending on in which IDE you people are working there. So all are whatever I am suggesting here. Not only these things, there are multiple, many more are there. Okay, so if you search that on the net there, so you'll get list of all the IDEs that supports the C language there. Okay, so all these are supporting our C language in this case. Okay, you have the one kind of editor where you have to edit your or type your program. After typing your program, you have to save your program with an extension C there. Then you have to proceed with the compilation and execution of your program. So this is very, very important fact that I am dealing with. So in this case, I'll be showing the working of the working of your program using Dev C++. I have already installed Dev C++ inside my system. So I'll take one example and I'll try to show the same thing. So I'll show you how to save the program, how to type the program in the editor, how to save the program, then how to compile the program and how to execute the program. Okay, is that clear, students? I'll take one simple example. Is that clear, students? Hello?
Yes, ma'am.
Okay. So now I'll first show you the things. So you just tell me whether are you able to see that particular IDE or not. Okay, then I'll try to type the program on that particular IDE. Okay, can you see this IDE? Hello, students?
No, ma'am.
You can't see the IDE?
No, ma'am.
No, you can't see anything here? So you cannot see something like, okay, file, edit, search and all those things?
No.
No. Nothing can be seen till if I type something here, No,
I will be
ma'am.
able to.
No, ma'am.
Ma'am. Not.
Can you see?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
You can see, no? Okay, so now this is an editor. Okay, so now this is you can see here it is Dev C++. Okay, and it supports it provides what we call it as the IDE for typing the program here. This is just an editor where you are able to type your program. So you have to go to file there. So in this file you have to click on new and a source file there. Okay, it's going to open a particular editor for you all where you people are able to type your program. So let's type the program. Okay, first one is let me say I am interested to do the addition of two numbers. Okay, so I'll simply write the title of this as addition of two numbers. Can you see what I am typing on the screen? Can you see?
Yes, ma'am.
Okay, addition of two numbers. This is the comment section that I have written. Okay, so now to read this, I already mentioned we have to use the hash include function where I am going to use the stdio.h. So this is the header file that I am supposed to add here. I have added that. Okay, then I'll begin with the main. I already mentioned, so it's a best habit if you use something called as int main there. Okay, so let's begin with the open and a closing brace there. Okay, so now I'm going to type the program. So I'm saying typing the data type for this. So I'm going to use three variables, two variables, and one is to store the result there. Okay, I'll write that. So let me take variables as x, comma, y, and to store the result, I'll be using something like yes there. So I'm going to initialize the value for this x and y. Okay, I'm not reading it from the external device. Let me take it as x is equal to some value there. Okay, and y is equal to some value. Y is equal to maybe 10 here. Then I'll be doing the addition of these two numbers, x plus y. Then I have to print the same thing there. I'll be using printf statement. Okay, so I'll write the result is, or the sum is equal to percentage d. I'll write, okay, comma, what is the meaning? Yes. Okay, I'll just close this. Okay, last statement must be return 0. I'll be using that. Okay, so now this is how we type the program. Is this okay? So it is including the documentation session, then you have the preprocessor directives, then you have the main over here. Every program must have main there and followed by the open brace and a closing brace for this. So flower brace is different from the normal parenthesis, round parenthesis. Okay, this talks about, okay, this usually talks about what we call it as okay, so this usually we call it as the function. Okay, if you use the rounded braces there, these are talking about the function there. So main is a function here which is including all these commands over here. So I have just declared three variables x, y, and s there. X I have taken it as 8, y has taken it as 10, s is equal to the sum here. So it is going to take the summation of x plus y there. I am printing the same thing. So now soon after doing this, I have to save this program. So you have to go to again file there. So I'll just click on save. Okay, so it is going to save. Where you want to save, it is asking me where you want to save the program. Okay, so now I'll just go to the desktop there. Okay, so in this desktop folder, I'll try to create one simple folder. Okay, let me write it as CPS folder. I have created this folder. Okay, maybe this is already existing. Okay, so let me take CPL folder. Okay, so now I've opened this particular, created this particular file. So I'll just double click on this. Now I am going to type I am going to save my program. I'll give, this is my first program. So I'll just give the name of this as something like add, because it is adding two numbers. Add the extension of this program must be, this file must be .c. If you forget to write the extension as .c there, so it is never going to execute. Okay, it is unable to execute that, or we are unable to execute that program. It should have the extension as .c. I hope I'm making it clear. Don't write the extension as .doc. Don't write the extension as .xls. Don't write the extension as something like other than .c. Okay, so your file must be .c here. Then I'm going to save this. Is that clear, students? Is that clear, students?
Yes,
Okay, now we are
ma'am.
supposed to execute this program. How do I execute? Go to the tab called as execute here, click on execute. You have something called as compile here. Okay, so if I click on compile here, it is going to compile the program. So you can see something has happened over here. Okay, I'll just expand this so that you people can see that. Okay, so this is all thing that has happened there. Okay, errors 0, okay, no warnings, okay. So output file is able to, it is created the output file there. Okay, so now I am working on Windows, that's why it is creating an exe file. If I am working on Linux, it never creates the exe file. Please remember, it is going to create a.out file there. So I'll repeat my statement. If you compile the program, an object file is going to be created. Okay, so if we are working on Windows, it's going to create an exe file. But if you are working on Linux platform, okay, it never creates exe file there. It always creates .out file there. A.out file will be created in case of Linux. If you are working on a Linux operating system, Unix operating system, Ubuntu operating system, there it is going to create exe file, that is executable file, as A.out. But if you go ahead with the Windows, it always creates an executable file as .exe file. So here also it is creating a exe file. So before this exe file, once you compile the program, so it is just creating an object file. Once you run this, so that time it's going to create or it is going to execute that executable file or object file that is already created there. Is that clear, students? And it is giving me some results over here. So if you look at the result, it is showing me 18. Is this 18 is correct answer? The sum is 18. If you add x as 8 and y as 10. Yes. And it is telling us how much time it has taken to execute this particular program here. Okay, it has taken some 0.07989 seconds to execute this program. Is that clear? So you have to type the program in an editor there. So whichever editor, so every compiler has got its own editor there. Please remember, that's very important. On that editor, you have to type your program, then you have to save your program. Whenever you are saving, you have to save the program with an extension .c there. After doing that, you have to compile your program. That time it is going to create an executable file there. So if you execute that particular file, it's going to give you the output there. Clear? Is that clear, students?
Yes, ma'am.
Okay, so now let's look into this. So now I have used int main there. Okay, so if I use int main, but if I don't use return there, I'll just put it in comment. Comment means it is not at all executable statement. Okay, comment means you are not supposed to execute that, or compiler is not supposed to execute. It is commented. Okay, no work can be done on that particular line. So I've just commented it. Okay, single line comment, you already know, if you use two forward lines there, it is commenting that particular line. I've just commented it. Now I am going to save that because I have made the changes. Once you made the changes, you have to save that program. After saving that program, again you have to compile that program. Now check it out. Okay, what it is showing here. Okay, so now after that, I'll just compile it. Okay, so it is showing me the result. So in this case, sometimes it won't give you the error, but sometimes it is going to give you the error. Okay, so now some compiler automatically returns, even though if you don't return 0, so compiler sometimes automatically returns 0 and it executes that. Okay, but sometimes some compiler will not accept that. So they'll tell you people to explicitly write this particular return 0 there. Okay, so now let me take this. I'll write simply main there. Okay, so I'll just open this comment. Now I'll try to save this. Again, I'll try to run this particular stuff. Okay, now also it is executing the program there. Okay, so now because some of the things it is going to override. Okay, so it will assume that, okay, this is fine with the system. Okay, but in some cases, some of the compilers, they are very rigid compilers. So there you have to explicitly mention everything. Okay, in some of the compiler, something will be accepted. Is that clear, students? Is that clear, students?
Yes,
Hello?
ma'am.
Okay, so are you able to see the result also, no? Can you see the result on the black screen?
Yes, ma'am.
Yes, ma'am.
Okay, fine. Right, okay. Okay, now I am interested to read the data. Instead of giving like this, if I am interested to read the data there, so let me read the data. Okay, so explicitly I am interested to read the data. So I'll read that. Okay, so let me write something. Read inputs here. read the two numbers. Read now two numbers for me. So to using a scanner, if I am able to read the contents now, I'll read that. Percentage D. Okay, so I'm going to read two numbers, X and Y. Okay, X. Okay, so now I am not putting the semicolon in front of this. Okay, according to that, it has to throw me the error. Okay, let's check it out. Okay, because in C language, every statement must end with a semicolon. Look at the every statement in main program. So this is also ending with semicolon, this is also ending with semicolon, this is also ending with semicolon, this is also ending with a semicolon there. Right, so every statement in C language must end with a semicolon. I have not put a semicolon here. Let's check it out whether it is going to throw an error or no. I'll just save it. I have already saved it as add because I'm just resaving it. Okay, making a modification in the same file. Again, now I'm going to compile the program. Now look at this. It is throwing me the error. What it is showing me the error? Expected semicolon before yes. So before this comment, yes, it is asking us to put the semicolon in front of this. This is what it is asking. So this is how it is showing me the error. Go to the 10th line. Okay, so now I have gone to 10th line here and it is showing me. So before you go to yes there, okay, so the statement which is written before yes must end with a semicolon. So this was, I have not placed the semicolon here. That was it. That's why it was showing error. That if I put a semicolon in front of this, now if I store it and if I compile it, now it is going to eliminate that particular error. Now check it out. So it has successfully run that particular program. Is that clear, students?
Yes, ma'am.
Yes. Now I am going to run this. Okay, so now if I run, it is asking me read the numbers. Now I have to read the numbers now. So read any value, x as 10. Okay, so then something as y as something like 19. So result I am expecting it as 29. The sum it is giving me as 20. Is that clear, students?
Yes, ma'am.
So any doubts, please don't hesitate to ask the questions. I'm just showing you the structure of the program, how the program is executed. So I have used dev C++ as one of the compiler over here. Okay, there are multiple compilers that are available. Okay, and in our case, please remember .exe file is created, which is not true in case of the Linux or the Unix or the Linux Ubuntu operating system. But if you go ahead with the Windows operating system, it always creates an exe file. Clear, students? Clear,
Yes, ma'am.
students? Okay, so now I'll just try to show it. Whether exe file is created or not to you all in the folder that I've constructed or stored in the on the desktop there. Okay, just look into that also. Okay, I'll try to show it to you. You just check it out. Are you able to see that particular stuff or no? Can you see? Can you
Yes,
see,
ma'am.
student? Okay, so now look at
Yes, ma'am.
this. So this is the file that I have created, add.c, but this is automatically created. Initially nothing was there because in front of you only I have created this EPL. Okay, this is a folder on the desktop. You can see that folder. Okay, so if you look at this, so you can see that particular stuff is available in the desktop itself. So this is desktop folder and that you have CPL over here. So in this CPL you have, I have created only one file called as add.c. Okay, but add.exe is automatically created by your compiler. Compiler is going to create that. Is that clear, students?
Yes, ma'am.
Is that clear? Okay, this is
Yes, ma'am.
very important. Okay, so now if something has gone wrong inside your program, this exe file is never created by your compiler. You cannot see this exe file at all. So still have any doubts, you people can ask me before I proceed with the other bit of the C programming. I have not told you anything related to the command, what we call it as the commands related to the C language. Okay, I've just told you the structure of C language, how the C can be written there. Any doubts, students? Please feel free to ask the
Nothing.
questions. Don't hesitate.
No, ma'am.
Okay. I'll come back to this one. Okay, so one more thing I wanted to mention here. So I'll again go back to the program here. Okay, I'll just show you some of the things there. So can you see this program, students? Can you see the program?
No, ma'am.
No, no.
Okay, it's not visible. Okay, I'll just check it out. Now, can you see the program?
Yes, ma'am.
Yes,
Yes, ma'am.
Okay. So now please remember, okay, so now these things. Okay, so now printf, scanf, okay, so return, these are all the words are the statements. Okay, or you can simply say it is word, then we'll talk about statements afterwards. So these words are found inside the C language. Okay, so I cannot say it as I wanted to write it as print. No, it is not acceptable because you are learning that language means whatever words that are available in that particular language, you have to learn that only and you have to write according to program according to those words only. You cannot write those words or you cannot manipulate those words. No, I cannot, I am not interested to write it as printf, madam, I wanted to write it as print. I don't want to write it as scanf, I want to write it as scan. So it is not acceptable because these words are not understood by the C language there. So C language means you are learning that language means whatever words, whatever statement they are giving, you have to write like that only. So by mistake, if you type this only print, okay, then if I execute this program, so let's look into this. It is telling me, okay, it is throwing me the error there. So it is showing me print. So this is not defined inside the C language. That's what it is conveying. Okay, so you have to write the syntax is given by the C language itself. So you cannot write whatever words you know. So you have to write the words that are available in that particular language. Okay, so this is called as a syntax error. Okay, the words that is available in the C language, that words you have to write. If you are unable to write it in a different manner, okay, then it's going to throw you an error. So that word is missing, that word is not found inside the C language, something like that. So we call it as a syntax errors. I hope I'm making it clear. Is that clear, students?
Yes, ma'am.
Okay. So after writing printf, I have to open a brace. Okay. Then I have to type something inside the, inside that particular brace. If I, instead of this, if I write something like this, I take this print, okay, and I'll type this after this particular closing brace. If I try to run this program, okay, I'll just save it and I'll try to run this. Again, it is going to throw me an error because this is not the proper grammatical sentence in the C language. Because whenever you write this form the statement, so you are going to school, you'll be saying, I am going to school. You never say that going school, I am. Do you say something like that?
No, no.
No, no. So if you are saying, if you want to say, I am going to school, you'll say, I am going to school. You never say that going to school, I am. Something like that. It is not acceptable. You have to write the statements using a proper, semantics, grammar. So that grammar is very important for us. Here also it is true. However, format that is given by C language, you have to adopt the same format. Okay, so after printf, you have to have an opening parenthesis means you have to have an opening parenthesis. Okay, so that's what I am trying to convey. So that's what we call it as semantic errors. Okay, semantic error means the grammar associated with that particular statement. Okay, if you misplace that, then it's going to throw an error there. How it is thrown an error here. Okay, so it is not understood what is this printf statement, where you have written. It is simply saying some error there because it is not able to understand what you have written there. Is that clear, students?
Yes.
There are two types of errors. One is the semantic error, another one is a semantic error. Syntax means, okay, so whatever spellings that are given, so instead of that, if you write your own spellings there, then it is not acceptable. That we call it as a syntax error. and whatever format they have given to write the particular statement inside the C language, if we change that, then again also it is going to throw an error. That we call it as a semantic error. Clear?
Yes, ma'am.
Okay. So one more thing. Logical error. Logical error are not, okay, logical error are not detected by your compilers. Please remember. So I have given, it is going to do the addition of two numbers, but I have written it as x minus y. So it's going to give me x minus y only. It is not making it as plus and it is giving you the result there. So that logic is not changed by the system there. It does not have that much intelligence to change the logic of the program there. Okay, so now I'll just run this, I'll just show it to you people. I hope I'm making it clear. So logical errors, it is not throwing any error. If I run this, it's going to give me the proper result there. Okay, I'll enter some number 19, okay, something like 20, or let me take it as maybe 10 here. I'm expecting it as 29, but I'm going to get it as 9 here. So I got this as 9 here. Are you getting it as 9? Hello?
Yes, ma'am.
Are you getting it as 9? But what is your expectation out of this program? What is your expectation out of this program?
Addition.
Addition, but it is doing subtraction. Okay, that is not identified by your system. It's a logical error. Logical errors are not corrected by the systems or the compilers, and it is true for any of the languages. Please remember. I have written it correctly, madam, but I didn't get the output. It was executing, madam. Many people will say these statements. Okay, because your logic is not right, correct there. You have written different logic. You have written wrong logic for getting the output there. Okay, but students always, okay, always, take in a different sense, and they always quarrel with the faculty. Madam, my program was correct, madam. I was written it correctly, but I didn't get the output, even though there was no errors. Here also no errors, but I told you people to do the addition, but it is giving me the subtraction of the results there, are the two numbers there. Whose mistake? Is it mistake of faculty? Do you feel is it a mistake of a faculty?
No, ma'am.
No. So students, you people are making that mistake. By chance, instead of pressing plus there, you pressed it as minus. It's your, you made a mistake there, right? So that kind of errors are not defined by, are not identified by your compiler, and don't expect it to do that. If it start doing that, okay, then every human being is replaced by machine only. Please remember, this is very fact that I am talking to everybody. If system starts doing all these things, if it start writing the program on its own, then we don't need, okay, we cannot stand anywhere on the earth. We will be thrown out of the earth. Machines are going to override us. Okay, they will become the kingmakers. I hope I'm making it clear. This is very important fact that I'm dealing with. So be, particular about the logic. Think in different and try to get the output out of the programs. So clear everybody, this is how you have to execute the program. I've told you the steps involved in executing the program. Still have any doubts? You people can ask me before I go ahead with the next bit.
No, ma'am.
No? Okay, we'll proceed with the next bit. All right. Okay, good. So anytime you people can ping me, you have any doubts? Okay, so now I'll go ahead with the next bit of it. Again, you have to tell me whether slides are visible to you or no. Okay, before I proceed with it.
Yes, ma'am.
Yes, ma'am.
The slides are visible to you all? Can you see the slides?
Yes, ma'am.
Right. Okay. So
No,
now
ma'am.
you cannot see?
No, ma'am.
Okay.
No, ma'am. Ma'am.
Okay, I'll just check it. Now check it. Can you see?
Visual, ma'am.
Yes, ma'am. Yes, ma'am.
Visible? Okay. Good. Okay. Now we'll start learning the new language, C language. Okay. How you learn the other languages, in the similar fashion, we'll try to learn this C language also. Right? But we have to, as we people are talking with the system rather than a human being, and whatever things that are given by that particular C compiler, we have to learn the same thing. right? So what are the things that are available in C language? Okay, look into this. Okay. So you have the alphabets. As usual, you have alphabets in the any languages also. So we have something called as tokens. Tokens are nothing but the words that we usually have inside our languages. Okay, you take any languages, in every language there are the words, and we'll try to combine those words to form the sentences. Then we have something called as the data types that supports these tokens that we people are using there. Then we have something called as variables, because we always play with the mathematical kind of stuffs in languages. Okay, that's why we need to hold the data there. That's why we use the variables there. And we have something called as the constants there. Okay, what is the meaning of constant? We'll be looking into that also, but not right now. Okay, so once we move into the next slides, we'll be talking about that also. First, we'll go in depth of tokens, alphabets, then we'll talk about the data bytes and data types and other bits. Okay, so alphabets, you already know alphabets. Okay, so now, okay, so before I proceed with that, how you people are learning the other languages in the similar fashion, you are learning this language also. So there is no difference at all. So if you look at the last statement, what I have given here, you have something called as the alphabets. First, you need to learn the alphabets found in C language. Then you need to know the words that are found in the inside that particular C language. Then try to form the statements, and only those you have to learn only those statements which are valid in that particular C program there. And set of statements is leading us what we call it as a program. But whenever you write the program, logic is added by the programmer there. So simply you are not writing the statements, but that statement, whenever you write those statements, it includes the logic of the human being also. Okay, then only I call it as a program. Otherwise, it is simply a set of it becomes simply a set of instructions there. Next, alphabets, first stuff. So what kind of alphabet supported by C language? So if you look at this, okay, so look at this. You have the letters, small a to capital, okay, small a to small z, capital A to capital Z. All or the letters that are valid can be used inside the C language. There is no issue in this. And okay, this is very important fact I am telling you. So these are all the alphabets that can be used inside the C language there. The digits that are supported by this is 0 to 9. And what are the special symbols that are supported by C language? So you look into all the symbols. Okay, these are all the symbols, because in one or the other stuff we people are using this. You already know we have used the the hash function. We use the because I have written one simple program there. I use the percentage sign. I use the ampersand sign in a what we call it as scanf statement there. We had this opening and a closing parenthesis. You have something called as plus sign, equal to sign was also used there. Okay, we had this flower braces also. We'll be seeing all these, whatever you are seeing, the symbols here, we'll be using all these symbols inside our program there. Okay, or inside our C language there. So here you have something called as the white spaces. Okay, so now what are the white spaces that are available? You have the new line characters there. So how do we use? I'll be talking about that also. You have something called as the small space. You'll be writing something like I said you about whenever you write the return, after return you are going to leave a space there. Okay, so if I written something like int there or main int there, okay, after int I left a space, then I wrote something called as main there. Main, opening brace and a closing brace. Then afterwards I write int there, then I left a space there, x comma y I wrote there. Okay, this space, okay, this is what is the meaning of this space there. Okay, so you have to take care of all these things. You are not supposed to write something like this. This is not acceptable in C language. Okay, so now you have to have the bifurcation between these variables with this particular stuff here, right? Okay, then that's what we call it as a white spaces. You have the horizontal spaces there, you have the vertical spaces there. Okay, so these things we usually play whenever you are interested to type something, display something on the screen there. Okay, so now how can we use these things? We'll be looking into that also in the printf statement. Okay, not now. So these are all the variety of braces that you people can play with. Okay, so we call these as a delimiters. Okay, so this is delimiter means which is going to do the separation between the two things. Okay, you have two stuff there. We wanted to have the separation between those two. Okay, because whenever I take here, let me take one example here. If I write int space, then x I'll write, then y. Okay, So I have written x int, okay, then followed by x there, then y. So I cannot write x space y there. It is not valid. I have to separate these two using a delimiter called as a comma. So the comma is acting as a delimiter between these two stuffs. Okay, I can use semicolon here. So this semicolon is just separating this particular statement with the next statement that I am going to write there. Okay, so now these are all the things that are allowed are found inside the C language. So I hope I made it clear about the alphabets that are used inside the C language. Any queries related to the alphabets? Small a to capital, small a to small z, capital A to capital Z, all numbers 0 to 9 numbers, all special characters that are available on the keyboard there, white spaces, okay, maybe a tab there, single space there, vertical tab or multiple spaces there, right? Delimiter, okay, so now you have variety of parentheses, okay, comma, semicolon, all these things can be used as the delimiter for your programs there. Is that clear, students? Is that okay? Is that okay?
Yes, ma'am.
Okay, so go ahead with the tokens. Now we are learning the words found inside the C language. Okay, these are the words that you people are supposed to use inside the C language. What are the variety of tokens, okay, that are allowed inside the C language? If you look at this, okay, first you have something called as, we call it as a C tokens, and maximum times in the final exams they ask related to C tokens. Explain, okay, list and explain the C tokens available in C language or C compiler. You have to write all these things, right? So which are the tokens? So keywords, identifiers, constants, strings, special symbols, operators. These are the variety of tokens that are available in the C language. So keywords. Keywords are the words that are available in the C language. These are default things. These are all available in C language itself. I'm not writing. Okay, so this int is available in C. This is available in C. Not only these things, there are 32 these kind of words. Next slide there. Okay, these are the keywords. Then you have something called as identifiers. Okay, how do you identify the function, something like main there? So similarly, you are going to write your own user defined function there. So you have to identify the function there. For that you have to give the name. So those things can be called as the identifiers. So how you write the, or how do you identify the values for the particular variable there? So that variable is also called as an identifier. Okay, so now, so very identifier means which is going to identify something, and it is going to inform this is what I am identifying inside the program to the compiler there. That's what we call it as an identifier. We'll be again looking into these things in little depth in the next slides, upcoming slides there. Okay, so constants also will be looking, but remember these are the variety of constants that are available. So I am listed only limited there, variety of constants that are available. Okay, so look at the strings. Strings must be always written inside the double quotes. You're not supposed to forget that. Strings must be always written inside the double quotes. What are strings? Strings are nothing but a set of characters. Right? Anything? Set of character. If I write A, B, C, D, A, B, C, D is a string. If I write this in a double quotes here. Okay, anything? A set of characters which is written inside the double quotes is termed as a string over there. Okay, next you have a special symbols here. So this is kind of special symbol that we people are using here, and this is talking about the functions. This talks about the arrays concept there. Okay, so what are these things? Again, we'll be looking into those terms. So whenever we talk about the functions and the other stuff there. Okay, so now we have the operators. Variety of operators are there. I listed only few here. Okay, addition operator, into operator, plus operator. That is incrementer operator and decrementer operator here. Okay, these are the tokens that are available in C language. Let's go ahead with the keywords. So these are the predefined keywords found inside the C language. These are all the keywords. Okay, I hope I'm making it clear. These are the keywords available in C language. What is the meaning of keywords? So these are given by C language. We are not supposed to take it as a part of any of the variables. You cannot use these as variables. I cannot use int as a variable. I cannot use this because this is a keyword. Keywords are given by the C language. These are all the keywords that are available. I think there are nearly 32 keywords that are available. And using only these 32 keywords, we are able to write any kind of a program in C language. Only these things. We are not diverting from this. We'll use only these 32 are keywords, and we are able to write the program. Okay, anything, you just try to combine these things and form a statement there. So this gives you the statement of that particular C language. Type def, switch, struct. Okay, we have particular, statements that are related to these particular keywords. How do we write that? Once we learn the syntaxes, learn the statements related to the C language, there we'll be looking into these things. But don't worry. But remember, these are the only keywords that we are playing with. We don't have other than these things. C language plays with only these words. Isn't it surprising for us? Only these keywords are helping us to write a biggest program in C language, because you know that Linux is written using C language. In that we are using only these stuffs. Check it out. Is that clear, students?
Yes.
Right. Okay. So now, what are the meaning of these things? Once, because in upcoming slides or upcoming modules, we are learning only these things only. Okay, so how I can use character, how can I use int, how can I use double, else, enumerated, extern, float, for, go to, everything. We are going to use these things, right? But in a systematic manner. We have the identifiers. Okay, so identifiers are not the keywords. Keywords cannot be identifiers. Students have a habit of writing these keywords as the identifier. Maximum students will do that. Please don't do that. Identifiers are just identifying the user-defined stuffs. Okay, I wanted to store one particular value inside a variable there. So I write it as x. Okay, so I write it as x. X is what we call it as an identifier. I wanted to write one user-defined function. I write my function f1, something like this. This is the identifier. Okay, this is identifier. But the keywords, if I take if cannot be keyword, int cannot be keyword, double cannot be keyword, then cannot be keyword, auto cannot be keyword. Identifier. Keywords cannot act as the identifiers. That you have to look into. That you have to take care. Many students make that kind of a mistake. They always pick the words from the keywords and they write it as part of the identifiers there. That is not correct. Please remember, this is very important fact that I am telling. Okay, is that clear? Identifiers are just to identify something inside the language there, whatever you are going to write. So these are not the keywords. Keywords cannot be identifiers. Then how do I define these identifiers? There should be some procedure to write the identifier. What is the, so there is certain rules that we need to follow that to write the identifiers. So what I'm going to write there? So I'm going to write this. So any identifier can begin with, any one of these things. It can begin with any one of these stuffs. It can begin with small a to small z, or any character starting from capital A to capital Z. Okay, either it can start with any number starting from 0 to 9 there. Okay, letters or digits can be starting alphabet are part of the identifiers there. Whenever you write the identifier, you can use that. So how can I write that? So if I write x0, okay, x0, if I write like this, so I've used a letter, alphabet here. Okay, this is my, what we call it as a digit here. Okay, this is a proper identifier. Because it is asking, it is telling me that rule. So I am accepting that. Okay, so you have to have the particular characters followed by what we call it as the numbers. If I simply write x, that is also acceptable because it's containing what it is containing. Identifier must have maybe a character, that is alphabet, or maybe a digit there. Okay, the only special character that is allowed to write the identifier is underscore. It's not hash, it is not dash, it is underscore. So if I write here a underscore 0, it is not a dash 0. So this is not allowed in C language as an identifier. A dash 0, okay, A underscore 0 is valid, this is not valid because this is dash here. I hope I am making it clear. This is very important. Except underscore, you cannot use any symbols. I cannot write it as A plus 0. This is not valid. I hope I am making it clear to everybody. Only underscore is valid to write the identifiers. Okay. So identifier names must be unique. Okay, so whatever identifier, so if I have written something like x0, so I cannot write one more identifier as x0 there. There is a conflict between these two. So that's why whenever you write, you have to write the identifiers very clearly and uniquely. You have to identify it very uniquely. So if first one you are writing it as x0, second one you write it as, okay, x0, x1. That is okay with us. Our first one is x underscore 0. Second one you want to write it as x underscore 1. That is also okay with us. No problem. Okay. So now, so next one is. So if you look at this, the first character, whenever we write the identifier there, the first character must be an alphabet. Nowadays, okay, so it can, if it begins with the numeric also, that is also acceptable, but it is not the right way of writing the identifier there. So it must start with the alphabet, even though it starts with the underscore, that is also acceptable. Okay, what it is talking about, rule is telling me that, so whenever you write, if I write underscore x or x1, something like this is valid one. Okay, so if you write something like 1x, usually it is not accepted in many of the compilers. Not all the compilers, but maximum compilers. In NCC, it never accepts this. Okay, ANSI, but C99 accepts this kind of stuff. Okay, so now we'll not worry about C99 right now because we are studying ANSI. We'll stick on to ANSI there. So this is not accepting this kind of stuff. If it is something like 2y here, 2y is not accepted by the compiler here because it is not starting with the alphanumeric, the alphabet there. Is that clear, students? Is that clear, students? Hello? Hello?
Yes, ma'am.
Okay. Okay, so now say about these two and I'll wind up the class. Okay. Next one is, so whenever you write the identifier, what is the size of the identifier you people can take? So it is supporting you to write 31 characters. It doesn't mean that you have to use all 31 characters because you'll waste in your time in typing the 31 characters itself. Okay, so now, so it is supporting 31 characters. It is up to you people whether you want to use the number of characters inside the identifier as how many, it is left to you people. Sometimes students will use only one character, that is also fine. Some students will use 10 characters, 5 characters, 4 characters. It is left to the end programmer who is going to use or type the identifier and define the identifiers there. Okay. Okay, so now please remember, it never allows the white spaces. I cannot write x space 1. This is not a valid identifier. Okay, it is not a valid identifier. Okay, so please remember. So, and next one is identifiers are not, okay, so now case sensitive. The meaning of that is, if I define it as something like, let me define. So I have defined something like max as max 1. So this is one thing that I have defined. So whenever I am using this inside my program, I have to write it as capital MAX1 only. Here I have defined it as max 1, and if I am writing it as max 1 inside my program, then it will say that this is not defined identifier. It is going to throw an error telling that this is not defined. Okay, it is case sensitive. I hope I am making it clear to everybody.
Yes,
Clear,
ma'am.
student? Okay, this is very important. So if you can look into the examples of this before I close the session. So now name is one identifier because it is containing a set of characters. So USN is starting with underscore. It is also valid. Okay. So now is it a valid identifier here? Is it a valid identifier? Make
No,
it
ma'am.
fast.
No, ma'am.
Why?
Yes.
White space.
Very good. So there is a space between these two. Okay, space is not valid. That's why it's not a valid identifier. What about this?
Identifier.
Yes.
Very good. Valid
Identifier,
identifier. What about this?
No, ma'am.
No, because it begins with numeric number. What about this?
Yes.
Little louder, make it fast. Valid or invalid?
Yes, ma'am.
Valid. Okay, what about this? Valid. Okay, so now if you are able to identify the identifiers correctly, so now you have almost, okay, so now I mean you are able to write the identifiers inside your program. So that much guarantee I can give you. Okay, so with this I'll conclude my today's session. Okay, so before I close, I'll take the attendance. Please be there only. Okay, don't go anywhere. Okay, don't. Okay, so go to, I'd switch over to another stuff there. Okay, so in the next class, we'll be dealing with the extension of the same thing.